we are talking about how to use theoretical probability or experimental probability, which could also be called relative frequency, in order to make predictions about what will happen in a real world situation or in an experiment. So, our learning target today is I can use theoretical and experimental probability to make predictions. Please write down the date that you're watching this video. Write down your what you already know about this topic. So you already know about theoretical probability. You already know about experimental probability. We have not used those things to make predictions yet, but you can still write what you know about experimental and theoretical probabilities by themselves. There is no vocabulary today, so get those things, pause the video here, get those things written down, and then restart when you're ready to go. All right, we're going to start with predictions with theoretical probability. So if we look at this spinner here, what is the probability of landing on the letter Y? Well, we've been doing this. I see that I have one section that has a Y in it out of 1, 2, 3, 4, 5, 6, 7, 8 sections. So that means that my probability is 1/8, which I can also write as a decimal by doing 1 divided by 8, giving me 0.125. And I can also write that as a percent by taking my decimal and multiplying it by 100 and getting 12.5. That is the part we've already been doing. So my new problem is how many times can I expect to land on the letter Y if I spin the spinner a total of 40 times? So this is what we're going to be doing with making a prediction. We're starting with what we know. Probability is 1 out of 8. And then we're using it to make a prediction. If I do this 40 times, what's going to happen? And I'm going to do this by making a proportion. Proportions are a super all of math, and this is a really good time for them. So I know that my probability is 1/8. So that is going to be the left side of my proportion. I want to know how many times I will get it out of 40. So 40 goes on the bottom right. And my unknown is how many times it will happen out of 40. Now all I need to do is solve this proportion. Looking at this, I see that 8 times 5 is 40. So I'm just going to do 1 times 5, and I get the answer of x equals 5. The last thing I want to do is look at what does this mean for the problem. My question was how many times can I expect to land on the letter Y if I spin the spinner 40 times? So I would expect to land on the letter Y 5 times. My answer would be 5 times. In Schoology, you'll just put the letter 5. You would just put, sorry, the number 5. But it's important that we know what this means. If I spun the spinner or spun the spinner 40 times, I would expect to get the letter Y 5 times. Okay, let's look at a couple more problems and see a couple more ways this could work. Henry rolled a number 1 through 6 cubed, so that's a regular dice. Sometimes math problems, and this could include on your MAP test, it could include on an MCA test, it could include on a lot of things, we'll call dice number cubes. So a 1 through 6 number cube, a total of 360 times. How many of the rolls of the number cube should Henry expect to land on an even number? Okay, so to solve this problem, the first thing I want to know is I want to know what is the probability that I roll an even number if I roll a dice. So the even numbers on the dice I know would be 2, 4, and 6. So there's 3 ways to get an even number, and there are 6 total sides. So my probability of getting an even number is 3/6, which simplifies to 1/2. Now I want to use this to make a prediction. If I'm going to roll it 360 times, how many times will I get an even number? So this is where I use my proportion. 1/2, that's my probability to start with, equals something out of 360. See if you can solve this proportion on your own first, and then restart the video to check your work. So looking at this, the relationship I see right here is that this is just a nice divide by 2. So all I'm going to have to do is 360 divided by 2. You could have also looked at this relationship right here. If you've done 360 divided by 2, you would have seen that this is times 180. And then you could do 1 times 180. Either way, we're going to get that x equals 180. That means that I would expect to land on an even number 180 times if I rolled the dice 360 times. An important thing to remember about predictions is that we are not expecting this to be perfect. I know that if I actually roll a dice 360 times, I could get a variety of things. But I would expect to get either 300 or I would expect to get an either number 180 times or at least close to 180 times. And if my answer was wildly different than that, I would wonder if something is wrong with the dice. Let's look at this one. If a 1 through 6 cube is rolled 240 times, predict the number of times it would land on an odd number. So this is going to be your first check for this video. So we're rolling a number cube. Again, this is a dice, so it's very, very similar to the last problem. But this time we want to know the probability of rolling an odd number. So I know that the probability of rolling an odd number, I have to think of how many numbers are odd on a dice out of how many total numbers. Then I'm going to use that value to set up my proportion. So first find the probability of rolling an odd number on a dice. Then use that to fill in your proportion to predict how many times out of 240. It's very, very, very similar to the last problem we did. This time we're looking at odd numbers out of 240 rolls. So that will be your first check for this video. So pause the video here, get that problem done, and then continue when you're ready. So next we want to be able to make predictions with experimental probability. Remember, experimental probability can also be called relative frequency. Those are the exact same thing, just depending on the problem, depending on the source of that problem, depending on the context, it may call it experimental probability and it may call it relative frequency. Experimental probability and relative frequency, those are actual results from an actual experiment. So looking at this problem, we want to be able to use the relative frequency to now make our prediction. We want to use what actually happened instead of what should happen in the theoretical world. So you rolled a number cube 50 times. Your results are below. We have each number and how many times it was rolled. Based on the relative frequency, how many times would you expect to roll the number 6 if you rolled the number cube 250 times? Now, it's really important here that we see that this is based on the relative frequency. If this had said based on theoretical probability, I would find the theoretical probability of rolling the number 6. The theoretical probability is just 1 over 6. But that's not what it asks us to do. It asks us to use the relative frequency. The relative frequency here of rolling a 6 was 10. I got a 6 10 times out of 50 rolls. So my relative frequency is 10 over 50, which I can simplify to 1 over 5. I can tell right away that is different than the theoretical probability. The theoretical probability of rolling a 6 was 1/6. My relative frequency, what actually happened, was 1/5. That's okay. We're now going to use this 1/5 to use a proportion. So based on relative frequency, that means in my proportion, I will use the 1/5, that is the relative frequency, put that on the left side of my proportion, and I want to know how many times I would get this out of 250. When I go to solve that, I say, okay, well, this is divide by 5, so I'll do 250 divide by 5, and that 250 divided by 5 is 50. That means if I rolled this dice 250 times, based on what actually happened in my experiment, I would expect to get a 6 50 times. All right, let's look at another example. Because for this example, it's a little bit tricky, the one that we just did, thinking about the relative frequency when we know the theoretical probability as well. We can see that this dice might not be a fair dice because it's rolling the number 6 more often than we would expect it to. So one way that relative frequency is used a lot is in situations where maybe we don't have dice, we have something a little more unpredictable. So for our next example, a company manufactures buttons. A quality control inspector finds 2 defective buttons in a batch of 300 buttons. So how many buttons would you expect to be defective in a shipment of 20,000 buttons? Okay. First thing we're going to do is we're going to find the relative frequency of a button being defective. Our problem says that there were 2 defective buttons out of 300. So my relative frequency was 2 out of 300. That's how many times a defective button occurred. I can simplify that to 1 over 150. Now I want to make a prediction. So my proportion will be 1 over 150 on the left side. And I how many times this will happen out of 20,000. So what I would like you to do right now is pause the video, see if you can solve this proportion on your own, and then come back when you're ready. So for here, I see anytime I have a 1, I know that this is going to be really nice. This is just divided by 150. So I'm just going to do 20,000 divided by 150. And that gives me x equals 133.3 repeating. Now as always, let's go back and double check what our answer means. About how many buttons would you expect to be defective in a shipment of 20,000? How many buttons is my question? Well, I can't really have 0.3 repeating of a button. If I had a third of a button, that button would obviously be broken. So that means that I'm going to round this to the nearest whole number. The nearest whole number, if I round 133.3 repeating, that'll just be 133 buttons. That's my answer. I would expect 133 buttons to be broken. Again, having a decimal point of a button doesn't make sense in this context. So I rounded to the nearest whole number. Now, there's a few other different types of questions that you could be asked. So we're going to look at a couple more of those. So for our next one, for which number or numbers does the relative frequency match the theoretical probability? So let's think about that, what that means. We know what relative frequency is. Relative frequency is what actually happens in an experiment. Theoretical probability is what should happen. So if I'm looking at this is die results for a 1 through 6 die, I know that the probability theoretically of rolling any of these things is 1 out of 6. So to see if my theoretical probability, which again, my theoretical probability for any of these is 1 out of 6, if I want to see if that matches the relative frequency, what I'm going to actually be doing is I'm going to be finding the relative frequency of all of these things and seeing if it matches. So I'm going to start by saying how many times did I roll this dice altogether. To do that, I just have to add up all of the things in this column. 16 plus 13 plus 35 plus 24 plus 33 plus 24. And I get a total of 145 times. That's how many times this dice was rolled. Okay? Now, I want to see if for any of these numbers, if I set up the relative frequency, will that simplify to 1/6? So let's start with the number 1. I got the number 1 16 out of 145 times. So looking to see if this simplifies, it doesn't. So that means that this can't possibly simplify to 1/6. So we're going to continue checking all of these. 13 over 145. Well, that I don't, if we try to simplify 13 over 145, well, only 13 goes into 13, and 13 doesn't go into 145, so we can't simplify that either. Let's try 35 over 145. All right, well, those are both divisible by 5. That gives me 7 over 29. All right, well, that's not the same as 1/6. So let's check another one. 24 over 145. Looking at these two, I don't think that there's going to be anything that goes into both of those as well. If I try 145 divided by 3, I get a decimal. So that means this number isn't simplifiable either. 33 divided by 145 is not simplifiable. And then 24 over 145 we already determined was not simplifiable. So adding all of these numbers together, we find that none of them are able to simplify to 1/6. That means that none of these match the theoretical probability. If any of these had been able to simplify to 1/6, then we would have said that they're the same. But since none of them did, we have to say none of them match the theoretical probability. All right, this is our last problem. You roll a number cube 250 times, your results are shown in the table. We got the number 1 40 times, 2 42 times, etc. So the first thing is, what was the experimental probability of rolling a 4? Well, the experimental probability, again, that means that we're looking at what happened in the experiment. So I got a 4 50 times, and it tells me right here that we did this 250 times. So 50 over 250, and I can simplify that to 1/5. So now my question is, based on the relative frequency, again, this is important, experimental probability, relative frequency, that's the same thing. It means we're using this number. How many times could you expect to roll a 4 if you rolled the cube 1,000 times? So solve this problem for me, set up the proportion, and solve this to predict the relative frequency. And then this will be the second question for your check. So the second question for your check is, how many times could you expect to roll a 4 if you rolled the cube 1,000 times? Thank you so much for watching. Please let me know if you have any questions. Have a great day.